Hello everyone. So today I would be discussing about the increasing and decreasing functions and what is the meaning of concavity. So I have seen that many of the students have confusions regarding the concavity up and concavity down. So I would be clearing the concept today. So let's begin from here. So suppose we have a function y equal to fx. Okay. Now if we calculate the value of dy over dx, and suppose let's say it is f dash x, okay, and if this dy over dx is greater than 0 at any interval or at any of the values of the x-axis, okay, so suppose this dy over dx is greater than 0 at interval a b, right, then this fx is a increasing function or y is a increasing function. So if this condition fulfills, then y is a increasing function. So this is a case of increasing function. Okay, and similarly it's converse. So y equal to fx, and if dy over dx, that is f dash x, is less than 0, okay, suppose in an interval pq, then it would be a decreasing function. So this function would be increasing in the interval a b, this function would be decreasing in the function pq if the value of dy over dx is less than 0 and dy over dx is greater than 0. So what is dy over dx? I have already explained in my previous video. Okay, so now I would tell you what is the meaning of increasing and what is the meaning of decreasing in terms of graph. So okay, here I will explain. So suppose this is the graph, okay, this is x-axis, this is y-axis. So suppose the graph is, let's say, in this way and then in this way. So when the value of y-axis is increasing with respect to the x-axis, value of y-axis is increasing from here to here. You see, these are the value of y-axis. This is increasing with respect to x-axis. So as the graph is moving on, the value of y-axis is increasing with respect to x, and up to here, up to this point, suppose this point is r, up to this point, the value of y is increasing with respect to x, right? Then up to this point, the function is increasing. Okay, so up to this, the function is increasing, and similarly this, from here r point to this point, the value of y-axis is constantly decreasing with respect to x-axis, so this is decreasing. So simply increasing function is when the value of y-axis is increasing with respect to x-axis, then it would be an increasing function, and decreasing function when the value of y-axis is decreasing with respect to the x, then it will be a decreasing function. So, and the condition I have already given, if the dy over dx condition greater than 0, then it is increasing. If the dy over dx is less than 0, then it is decreasing. So let's take an example. So suppose y equal to, we have a function y equal to, let's take y equal to x square. Okay, now if I make a graph, so before making a graph, I will tell you, I will firstly calculate the value of dy over dx. So dy over dx equal to 2x, right? So now you see that dy over dx is 2x. So now if I say the value of x is greater than 0, so when the value of x would be greater than 0, then the dy over dx value is also greater than 0. Okay, so if x is greater than 0 over here, then dy over dx would also be greater than 0, and if dy over dx is greater than 0, then this function is increasing. So when would be the condition we say that dy over dx is greater than 0? That condition is when x is greater than 0. So in this, if this condition is applied, then dy over dx is greater than 0. And similarly, if x is less than 0, then this whole value would be negative. 2 into negative value would be negative, and dy over dx would be less than 0. So dy over dx would be less than 0, okay, when x is less than 0. So from here we can analyze that dy over dx is greater than 0 if x is greater than 0, and it is less than 0 when x is less than 0. So now let's see the graph. So the graph of y equal to x square, if you plot on a graph paper, then you would see that the graph is like this. Okay. So now let's see what was the condition. The condition is that dy over dx is greater than 0 if x is greater than 0. That means for x greater than 0, this function is increasing, and similarly for x less than 0, the function is decreasing. So you can verify it from this graph, from O to this, like these are the values from next to the origin in the right. All the value of x-axis would be positive, and you can see that the function is increasing. Why? Because as we go ahead towards the x-axis, the value of y-axis is going up. You see, it is increasing. And similarly, when x is less than 0, the function is decreasing. You see, suppose we are this is a negative x-axis. Okay. Now if you move on to the right, then you see the function is decreasing, 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 decreasing. Okay. So this is the example to verify whatever the concept I explained earlier. So hence verify, right? Now I would give you a next example of, let's see the example first. Suppose we have a function y equal to e power x. This is exponential function. You know well, value of e is 2.713. So this is the exponential function. We denote it. And if I plot a graph of e to power x, then firstly I want to have the value of dy over dx, whether it is greater than 0 or less than 0, and in what values of x-axis it is greater or less than. Okay. So by calculating the value of dy over dx, we have ex. You all will be knowing that the formula of dy over dx for ex is itself ex. Okay. Now, if you put any power to a certain value a, b, c, d, 1, 2, 3, 4, 5, 6, 7, 8. If you put power to a certain value, then definitely that value is going to be positive if the value is positive. If the value is positive 1, 2, 3, 4, and you are putting a power on that value, then definitely the result would be positive. So dy over dx equal to ex, it would be always greater than 0 for all values of x greater than 0 or x less than 0. That means for all real numbers. So for all real numbers, the value of ex would be greater than 0. So that means dy over dx is greater than 0 for all values of x. So for all values of x, the value of dy over dx is greater than 0. That means ex is always increasing function. Increasing function. So ex is always increasing function. So if we see the graph of ex, this is x, this is y. So if I put x equal to 0, then e to the power 0 equal to 1. So if you plot it in the graph paper, then it would be like this. Sorry. Like this. Okay. It is going towards infinity, minus infinity. Okay. Now this value of it is approaching towards 0 whenever we are going to the minus infinity, right? So this is a function of e to the power x. So this is all, guys, and I would be talking about the concavity concept in my next video. Okay, so thank you guys.